Hello, how are we doing today? Good evening. And here we're just creating a new project. So let's go ahead and create a new project. This one we're just gonna call it a. Okay, come here. Used to get lost here with a small screen. I'm so used to it with big screens. Okay, let's just call it demo one. Okay, and we're just going to wait for approvals. It's fantastic. And we're just going to work locally on the main branch. That's fine. So what do we want to build? So we want to kind of move away from vibe coding, and we want to explore a little bit more disciplined vibe coding. So at this point, I want to be able to instruct the model what I want. So in this case, I can say, let's create a. So let's create a spec sheet. Let's generate a spec sheet for the following project. So now at this point that we want to create a spec sheet, what is the kind of project that we're going to be working on demo one? So let's actually pick just do a calculator. Calculator. The tool we are going to design. Visual is important. So let's find the best layout that is most commonly found. Now, we are thinking about the visual, so we're kind of visualizing the tool as a calculator. Everybody knows that a calculator looks like as an application or even physically. So we're just going to go with something to see how this model can behave. This is going to be GPT-5, and we'll do medium, and we're just going to do fast. Okay, it's just going to use more tokens. With options to include advanced formula and constants, values used mainly in physics. Let's see, geometry, etc. Okay, so now what language want to do? So right now I have the application on Apple device, so I want to target Swift. So Swift is the language we are going to choose. We want to benefit from the best hardware locally. This machine. Okay, this computer will perform its computation more accurate. I'm kind of over engineering. Once you have the spec sheet, let's make a plan and compile and execute the visual application. Let it functional, modular, so what do we do here? So we kind of want for the AI to kind of generate. This is kind of over engineered for calculators because we can say just write me a calculator for Apple and just use Swift, and it most likely do a good job. But we're kind of over engineering it just a little bit. We're kind of thinking about what are the components that are part of the application, how we want the application to be illustrated, what it would contain, give it a little context about the formula and the constant values, because you're kind of designing a tool specifically for a certain function. You might not want a calculator with binaries and bitwise logic, maybe more oriented to a specific task. Maybe an agent will be accessing that tool, and you only want to give it certain access. So that's where I'm being very specific. Making it aware that this computer, it's an Apple and it's an M5. I think it would be able to infer that. Um, and just to kind of use the best registries or just the best capabilities of the hardware that it's being exposed to. Once it does that, make a plan, compile, and execute the visual application that is functional, modular, and ability to handle errors. So kind of letting you know, like, make sure you write the program that is appealing and it's strictly it's a pattern that we already are aware of, what we've seen before, and then it's functional, meaning, and modular, meaning that just use functional programming. Hopefully, it catches that, and ability to handle errors like overflow and this and that, etc. You can't over-engineer it for a calculator, but I just kind of wanted to give you an example that you want to spend more time thinking about what you're writing and designing. It makes it easier to debug. In fact, a good thing to do when you're working with this type of things, just kind of exploring. You want to document every step of the way. I know it's more tokens, um, and you see it's really good that it's seeing that it already has tools already built in, so it's already available. We didn't have to specify, install this compiler, and etc. But there will be a system, like if you're deploying this agent to perform a certain task, you want to be very specific what applications you want to install, making sure they're up to date to the latest version. You might want to have a tool to see if the version is it's been patched or any issues with that, depending where you're going to be deploying this application and services, right? So if it's very integral into a production system, you want to make sure that your agents are picking from the right source code. You can the right repository, that it's verifiable. Then there's some check and balances. So this is where we you can get more dangerous, and you have to be more compliant when you're dealing with all kinds of information. So kind of have to spend more time with our specification, and even then it makes mistakes. So you want to have something that's auditable, meaning you'll be able to audit. Even with AI being able to help you, you do have to have a deterministic outcome, right? You can't just write an application and expect that it's just going to be a beautiful calculator that has no problems, or it won't memory leak just because it should be smart enough. You have to be more specific depending on what is the concentration of the application. Again, we're over engineering for a calculator, so that's just kind of like how my mind is working right now. Again, we didn't provide names, what version. It's kind of like doing its thing. It's assuming let's call it a Swift PM. Let me see, that's what it's called? Swift PM, client cache, sandbox. Okay, it should ask me permission now for escalation. One thing I noticed, it's like 1,200 lines of code for this, really? Okay. I didn't think it was going to be that many lines of code, but okay. So it's very important to document, use a Git repository locally, and then you can make your commits. And even myself, trying to discipline myself of having like different branches, because a branch, basically, to my understanding, and I'm still new to this, a branch is kind of like you want to experiment with a particular feature, right? You don't want to necessarily include that in every version. You can kind of say, okay, I like this version that does this. Let me see how it looks like with these other version. So that kind of stuff. Your main repository is like the one that you want everybody to be your primary. So the wording is very self-explanatory. And technically, you can go to ChatGPT and say, write me a calculator in Swift, and you make the code and paste it, or HTML, and it would have been done a long time ago. But we wanted to kind of like see how far the AI system can take it, given that I did say include formulas and constant values regarding physics. So I do want some sort of, it would infer that you're dealing with somebody that is working with shapes, geometry, structures, but also wants some physics constants. It doesn't want to constantly write them or pre-compute them. Maybe they're too long. So we wanted to see how far this can infer what we're trying. Remember, it's just trying to autocomplete the next token. So like early renditions of this models, again, it has reasoning, but before that, it would just kind of give you something that was completely unrelated. So now this is a stronger connection. All right, just finished building it, and you see how long it's been taking. It's 3 out of 5. Right now, it's implementing a calculator engine, constant geometry helpers, and the Swig UI. Then it'll compile, test it, benchmark, and launch. And then it'll finish documentation, commands, verification, rollback, and reuse notes. So this is actually the proper way of doing it. If you're trying to create something, for example, if I give it complete control, it could run the calculator. The calculator could do. It could have misunderstood something, you know. Okay, so that's how it runs it. So when you're writing programs with Codex and any Quad, most people don't do this. It's a little bit more advanced, but I wanted to show like this is how you should be engaging. Like if you're writing a book. Okay. So let's actually take this for a spin. I reckon that okay, still working. 3 out of 5. It looks okay. We had no. One thing is we also didn't have any kind of input or context of how we wanted the visual. We just sort of kind of described it just a bit. So honestly, like you would just kind of sketch something out or draw something that you really wanted. Like, hey, I want it to be kind of rustic. You look like a real calculator. Can you do like a skin of this and then actually place that within the LCD location on the very top? You can be very, very specific, and then you're being very intentional with your design, and you know what you want. And that's actually what it is. I mean, you're not going to vibe code yourself to build a factory, right? You can kind of get a 3D model of a factory and kind of have everything 1-to-1 ratio of how it actually looks like in the real world. This is how you create real things. So, I mean, it's fun and play to imagine and do all kinds of stuff, but when we kind of building real systems, we want something to be solid. So, okay, cool. So this is actually the proper way of doing a project. You kind of try to be as specific as possible. This is just very short compared to how like a lot of harnesses are built with multiple prompts, multiple layers. But this is very nice, right? Because we know what it did here. It worked on it for 7 minutes and 43 seconds. It went through the entire process. And in fact, if you go into like fine tuning or training deterministic model, or you're trying to kind of enforce certain understanding on certain models for them to reason over, this is great because you see the entire process, what files were read, and you can see why did it read this file, why did it write this line of code. I mean, you can justify everything like this, but you'll be burning tokens and a lot of wattage, so not necessary. Last thing I can ask, run. And it's just, it would understand the run. It means just launch the application that we just compile, and it's in the release folder. It's a very common pattern, so let's go ahead and play around with the calculator. Okay, so what happens with 0 divided by 0? Cannot divide by 0. Okay, so we would think that Codex will do something like that. Okay, so it just gives you some values here. Times pi. Okay, let's go ahead and clear it. Pi. Can it work? No, so if I'm over here, it's already selected over here. Times pi. Okay. Square root pi. Okay. Well, it's a calculator. What can I say? Cool. And then it doesn't look the best. And obviously, okay. So let me show you what totally failed. Let's go ahead and I am a little bit lost. I do not know why I can't show it to you. There you go. That's what it looks like. Calculator that I just generated. Not the best looking calculator, obviously. Can we shrink it? Yeah. And we know the calculator works. Okay. Trailing input, mode for expression expectation. Okay. Here I put letters. So Codex is not that good. I should have known that typing random letters. I mean, we'll call it invalid characters, which is fine. I guess, would it have made K equals 2? No. K times 2? Oh, K times 3. K plus 1. So it ignored K. Okay, it's not that bad. It's just a calculator. Let's go ahead and close it out. Okay, we're back. So at this point, you have an application, and you can go ahead and continue making improvements to it. Now, what is the best way of making improvements? So the cool thing you can do is more of, let's perform a series of layout comparisons for the visual. Also, better error handling and flow of content. Okay. Take screenshots. And then perform test manually. Okay, that's it. So what do we do now? So we're just kind of saying, hey, I can say, hey, put the plus sign on the left. I can be very specific. Again, you can sketch it, draw it, you can do all kinds of stuff. But I'm trying to figure out, would the model be good enough to explore different layouts of the visual in parallel? Better error handling, so understanding that something about the flow of your arrangement of the screen. Could take a screenshot and perform test navigate it yourself deterministically. So it must have the ability to navigate the application itself agentically without any of the tools in Codex. Obviously, we're not going to do that. So it needs to be able to deterministically be able to send a series of events through keyboard or mouse or whatever it decides to do. So the cool thing is, this entire process that's happening here, it's where the beautiful magic happens in this harness, right? And this software that's crafted with all the specific rules, right? That you don't know what kind of, let's see, stuff that it does in between, and now it wants permission. So I'm gonna have to get Codex permission. It wants me to close and open it. Let's see. I ignored it for now to see if it does let me do it. Anyways. It says, can I read the display in the session? Yeah, but I don't want to start this again. So maybe it should know the arrangement of the layout. See, like for example, an agent, even though they request permission for certain resource, when we do deploy them, we must not expect that permission will always be granted, depending on the type of application. Ideally, it should have permission to all the means that it needs, but it should have alternative ways of figuring out. Well, I don't have visual, but I do have software that can take screenshots or have certain logs that kind of indicate location of mouse. It must think creatively, right? If it's a problem solver. It needs to be able to think different path. Um, it should take different paths. Um, and so what we do is we don't want our brains to rot with vibe coding. It's interesting that we can kind of observe its behavior, and then we can probably build better software by taking time to kind of observe how the model reasons. Right? Still working on it. We want to see how it reasons and how long it takes. Like, for example, we're in step 1 out of 6, believe. Let's see. Is he rewriting the entire application? Okay, inspect current implement, improve layout by default in your head. So it's going to try to capture, which you could, I thought it could already be able to do that. Okay. See how it messed up a little bit at the bottom. Let me see. That's visual. Let's see what Codex says. Okay, so it's asking me if I give it permission to control it. I try to download and launch the actual calculator. Okay, go. So now we should be able to give it control to control the calculator. Even though I messed up at the bottom there. I should understand that it's not the most appealing. There we go. You just give it that permission. So this is a cool thing that it can able to go in there and type in the buttons, but it should notice that, hey, the equal sign is not quite where it should be. I should make that change, and it should actually launch it again. Fixed. Now, that will be a whole different thing. How it should, how it determines what is the layout. That's an entire thing that we should. Right now it's doing. It's gonna divide 1 by 0. You kind of see, like, okay, cannot divide by 0. And depending, if you have a system that's building certain application, it has to be very expressive. Now, one thing I do see, and I'm gonna cut this video a little bit short here. It's already gone long, and now I'm building a calculator. But we're kind of over engineering and focusing on. We're kind of wasting a lot of energy right now, believe it or not, in something so simple as a calculator. But if an AI system can't create a simple tool as a calculator with enough function and be very deterministic. The calculator is very deterministic. Let's generate random numbers, and it bases that on something. Even if it's high entropy, well, we want it to be high entropy. But if you can't do something like that, then how are we supposed to colonize Mars? How are we supposed to do all these wonderful things, right? So someone has to kind of explore these ideas and kind of come up with the data in order to get the models to the next level. Okay. And then, when AI is dealing with these tools like this visual, like mouse, cursor, keyboard, that's a very human thing. So an AI system really just wants to solve problems, and they're just the best way it can do it is by using mathematics, using computation. This is computation, but this is more of a higher level abstraction. It's more of yes, you got the aesthetics and the convenience, but it's for humans. AI systems just have to learn how to bypass these parts just to kind of access to the higher realms. But essentially, if an AI system was mainly focused on optimizing low level hardware or even creating new hardware, then that's exactly what it would do. Um, Now, people will benefit from it because it can create really good hardware that poses a threat to national security, etc. But we want to stay committed to what we're working on. So what we have done, we have and this is a total of 12 steps. So 7 minutes and plus on the first generation. Probably another, so we probably spend 15, 20 minutes working on this calculator. It doesn't look anywhere close to a clean calculator because that wasn't our focus. Our focus was kind of a mixture of creating a tool and testing the tool. That makes sense. So let's see. Right triangle, okay. Of course, and I went ahead to take pictures of different states. This is kind of like a gather the evidence kind of test where if you have an agentic system that's building, like you look at the structure, this is beautiful. So we want to have our benchmarks, right? So we want to know our timestamps, what tools we use. Of course, it didn't get enough information to understand the hardware that we are running. Okay, blueprints. Kind of some of the things that we kind of mentioned, and then let me see. Version specs. I guess maybe the original spec plus its own expansion, and it's making this assumption based on data that it's getting from the environment and tools accessible, and Swift also mostly used on Apple devices. Then it takes screenshots, which is your collection of your samples of the application. The system's creating stuff you want proof, and then scripts, what it used to compile this, a source. How did it organize this? Okay, your main function. So just by functions. Okay. The test. Okay, so pretty organized, right? Now the most important thing is documents. And another thing that I kind of learned in a video that I watched, I have to go back and kind of revisit. It's documentation. Can the same model replicate the application just based on spec files? Don't know if there's a name for it, but giving enough context of an application with and then provided screenshots of the visual, that's why the screenshots are important, in order to deterministically create something that is high accuracy. And then you can kind of take this while and just test it to make sure if it's 100% or 99%, depending on the model across, the big flagship models. But this is just a little calculator that has been over-engineered, and when you over-engineer something with not enough context, you end up with the third-grade calculator that doesn't look anywhere close to. It's still functional, but it's not appealing. Plus, it's missing all kinds of stuff. But it did, follow the prompt pretty well, I would say. So yeah, this is our over-engineered calculator. It's just kind of an example of how we start with something so simple like this. We kind of follow the entire path. We add a little bit more input, and you have wasted 30 minutes of tokens. Don't know, vibe coding, but you were part of the entire process. It did make a lot of assumptions, which that's why it's very important initially to be very specific. And then also try not to use full access. So full access is complete, like, hey, there's an active intruder in my system, or something's happening. I need to catch it on the fly. I don't got time to give you input. So here you kind of give your convenience and privacy for it to go through things that it's going to make the assumption. It's going to just predict the next most predictable pattern and whatever, chain along the series of events that it's going, in its own reasoning. Um, so it could be dangerous because you can end up with a command or something or script that you didn't want to execute, and that script just kind of like factory resets the entire, I don't know, firewall or something. So that's the kind of stuff that can happen. So in this scenario, I do want approvals on this save because we kind of trusting that it would catch that. And then, this would be paranoid mode, which is like, I need approval for everything. So here's great because you can kind of steer the direction at every turn. So that takes more time. But if you're dealing with some sort of, simulation that it's working through, and you have built into it, this is what people don't understand. You can use AI, yes, to write code, but you can also use it to examine code or examine some sort of operation that's happening in real time. So let's say your job, right? You start this job, and you are responsible for overseeing an API or some sort of data collection that's happening ongoing, and you're supposed to be working with it. Or this is how the data is supposed to be looking like, but we need somebody actively creating information charts or expressing the information in different ways. For example, that has to be supervised. So this will be supervised. So we will be monitoring data, our behaviors, and making our own kind of work, our own repository. Let's say it's something that's only completely read only, so we can actually go by what we observe. So let's say I'm using it for my neurobytes, neurobytes.org, where someone has a problem, and sure, I can give complete control, but it makes a lot of mistakes, like especially if you're injecting PowerShell and you're kind of getting more of this information from the system. But if you be more specific, like the computer has a certain symptom, is crashing with a particular application, then we kind of gather data and say, well, let's examine what's running, what would cause it. This is kind of like the information the customer gave me. And then of course we take that model and data, we can build a deterministic path, and we kind of like create a dot in our database. Okay, this is something that we learned, so this is kind of like how we solve this kind of problem. And you kind of build your own tools locally. So this is what AI is all for. We can burn a lot of tokens over engineering, or we can actually look at existing system and say, okay, how can I solve real problems? So I think that's what I'm going to do on the next video. I want to give you an example, an introduction of how you can just kind of build software. Be more specific. Even if you didn't know how to build a software, you can say, build me a calculator that runs on Apple, and then please run it. Something simple like that. It would have given you probably something just very basic, and it would work just fine, most likely, because the model is very smart. But for the next level, and then of course I basically showed you the worst case scenario. Don't over-engineer something that is so simple. And if you do want to engineer it well, then be more specific with context and show examples. Like I could take pictures of calculators and kind of say, it must look like this. So now I create a constraint. But I think for the next video, I hope I didn't waste your time. You can like and subscribe. And I think I can be more specific with, more intentional what I want. And with an existing system, we can kind of pick a virtual machine or a computer that's performing some sort of computation, or maybe creating some sort of problem. Maybe we can create an environment where there's a problem happening, and maybe we can just kind of step into it slowly, and we can learn something that I don't know, or we can all learn together. But that's part of the exploration with AI. We just don't. The vibe coding is fine, but maybe we just have to go a little deeper and learn something new. So please like and subscribe to Zero Duckies Entertainment. And I have that calculator on the whole time. Man, diablo, ¿qué pasó? Please like and subscribe. I'm obviously new to this.